Hello students, today we are going to study structure of the atom. In chapter 3 we have learned that atoms and molecules are the fundamental building blocks of matter. The existence of different kinds of matter is due to different atoms constituting them. In this chapter we will learn about subatomic particles and the various models proposed by different scientists to explain how these particles are arranged within the atom. In your previous class, you have learned that when a glass rod is rubbed with silk cloth and it is brought near an inflated balloon, the glass rod attracts the inflated balloon. That is, when two objects are rubbed, they become electrically charged. Many scientists contributed in revealing the presence of charged particle in an atom. Eugene Goldstein, a German physicist, in the year 1886 discovered the presence of new radiation in gas discharge tube and called them as canal rays. The discovery of these rays led to the discovery of subatomic particles called proton. In the year 1897, Joseph J. Thomson discovered subatomic particle, the electron. Electrons are negatively charged particles and protons are positively charged particles. So, the protons and electrons present in an atom, they mutually balance their charge. Because electrons are negatively charged and protons are positively charged. And also, the mass of a proton is taken as 1 unit and mass of electron is considered to be negligible. The charge of proton is +1, whereas the charge of electron it is -1. It seemed highly likely that an atom was composed of protons and electrons mutually balancing their charge. That is, as protons and electrons, they have equal in magnitude but opposite in charges. So they balance each other. And it also appeared that the protons were in the interior of the atom, whereas electrons could easily be peeled off but not protons. We have learned Dalton's atomic theory in chapter 3 that suggested that the atom was indivisible and indestructible. But after the discovery of two fundamental particles, that is electrons and protons, that led to the failure of this aspect of Dalton's atomic theory. It was then considered necessary to know how electrons and protons are arranged within an atom. To explain this, many scientists proposed various atomic models. The first one to propose such a model for the structure of atom was J.J. Thomson. Thomson proposed the model of an atom to be similar to that of a Christmas pudding. The electrons in a sphere of positive charge were like the dry fruits in a spherical Christmas pudding. And another comparison that we can make is that with that of a watermelon. The positive charge in the atom is spread all over like the red edible part of the watermelon. And the electrons, they are studded in the positively charged sphere like the seeds that we find in the watermelon. So, Sir J.J. Thomson proposed that atom consists of a positively charged sphere and the electrons are embedded in it. That we can see, I already told you in the red edible part how the seeds are arranged. Same way, the electrons are embedded in an atom. The second one, the negative and positive charges are equal in magnitude, that we have already seen. So the atom as a whole is electrically neutral. This is the structure which is proposed by J.J. Thomson. Although this Thomson's model explained that atoms are electrically neutral, the result of the experiments carried out by other scientists, they could not be explained by this model. So, J.J. Thomson's atomic model was discarded. Another scientist called Ernest Rutherford was interested in knowing how the electrons are arranged within an atom. So Rutherford, he designed an experiment for this. And in this experiment, fast moving alpha particles were made to fall on a thin gold foil. So he selected fast moving alpha particles and also gold foil. So why he selected the gold foil for conducting the experiment, not of any other metal? The reason is that he wanted the thin layer as possible. So this gold foil was about 1000 atoms thick. So Ernest Rutherford, he selected a gold foil because he wanted as thin as a layer as possible. And alpha particles, they are doubly charged helium ions and they have a mass of 4 atomic mass units. So these alpha particles, these fast moving alpha particles, they have a considerable amount of energy. And it was expected that the alpha particles would be deflected by the subatomic particles in the gold foil. Since the alpha particles were much heavier than the protons, he did not expect to see large deflections. Now we can see what were the observations of Rutherford after conducting this experiment, this gold foil experiment. The first observation was this: most of the fast moving alpha particles passed straight through the gold foil. From the figure you can see most of the radiation, they passed straight, they moved straight through the gold foil. Second observation, some of the alpha particles were deflected by the foil by small angles. See the figure, some acute angles or the small angles, we can see they are the deflections made by some of the alpha radiations. Third observation, 1 out of every 12,000 particles appeared to rebound. That is, a very few alpha particles, they appear to rebound after falling in this gold foil. So these were the observations of Ernest Rutherford after conducting gold foil experiment. And from this, he made certain conclusions. Most of the space inside the atom is empty. The first conclusion was this: most of the space inside the atom is empty. How he made this conclusion? That is, because from the experiment he observed that most of the alpha particles passed through the gold foil without getting deflected. As they passed straight without any deflection, he concluded that most of the space inside the atom is empty. That's why they passed straight. Second conclusion, the positive charge of the atom occupies very little space. Positive charge of the atom occupies very little space. This conclusion was made from the second observation that very few particles were deflected from their path. in small angles we have seen. Then third conclusion, all the positive charge and mass of gold atom were concentrated in a very small volume within the atom. Because from the experiment he observed that a very small fraction of alpha particles were deflected by 180 degree. That indicates that all the positive charge and mass of the gold atom were concentrated in a very small volume within the atom. From these observations and conclusion, Ernest Rutherford, he gave the structure of the atom like this, or he gave a nuclear model like this. There is a positively charged center which is called as the nucleus, and all mass of the atom resides in the nucleus. There is a positively charged center in an atom called as the nucleus. All the mass of an atom resides in the nucleus. The electrons revolve around the nucleus in well-defined orbits. And the size of the nucleus is very small as compared to the size of the atom. This is the nuclear model suggested by Ernest Rutherford. But the model suggested by Rutherford also discarded due to certain drawbacks. What are the drawbacks of Rutherford's model of the atom? The orbital revolution of the electron is not expected to be stable. And we have already learned that any particle in a circular orbit would undergo acceleration. That means any particle that is moving in a circular path, they undergo acceleration. In chapter 8, motion, we have studied that. And during acceleration, the charged particles would radiate energy. Thus, the revolving electron would lose energy and finally fall into the nucleus. Because when it possesses acceleration, the charged particle, they radiate energy. That means there is a chance of losing the energy. When the electrons, they lose energy, there is a chance of the electrons to fall into the nucleus. And if this electron fall into the nucleus, the atom should be highly unstable. So if this happens, what we can conclude from that? The atom is not stable, it is highly unstable. So if atom is highly unstable, matter would not exist in the form that as we know it now. So, but we know that matter exists in the nature, so atom would be stable only. So that's why the atomic model suggested by Ernest Rutherford also discarded. And another model was suggested by Niels Bohr. In order to overcome the objections raised against Rutherford's model of the atom, Niels Bohr put forward some postulates about the model of an atom. We can see the postulates of Niels Bohr about the model of an atom. Only certain special orbits known as discrete orbit of electrons are allowed inside the atom. That means atoms, they have certain special orbits called as the discrete orbits for the motion of electrons. While revolving in these discrete orbits, the electrons, they do not radiate energy. And these orbits or shells, they are called as energy levels. And energy levels, they are shown in the figure. And these orbits are represented by the letters K, L, M, N, or orbits or shells. And also they are given as numbers. N is equal to 1, 2, 3, 4. That means K, which is the innermost shell, first number, N is equal to 1. That is L, N is equal to 2, like that. So postulates of Niels Bohr's atomic model, that is, only certain special orbits known as discrete orbit of electrons are allowed inside the atom. While revolving in discrete orbits, the electrons do not radiate energy. So I hope this topic is clear to you. The lesson will be continued in the next video. Thank you.